Hi all. Today we are going to discuss about the section of solids when the section plane is perpendicular to VP and inclined to HP. Okay, let us discuss a problem. A square prism of base 35 mm and height 60 mm rests with its base on HP such that one of its base edge is inclined at 30° to VP. A section plane inclined at 60° to HP and perpendicular to VP cuts the prism through a point on the axis 20 mm from the top of the prism. Draw the sectional views and true shape of the section. How's that question? Okay. So a section plane is parallel to HP, then the sectional top view will give the true shape. And if the section plane is parallel to vertical plane, then the sectional front view will give the true shape. Here neither top view nor front view will give true length because the section plane is perpendicular to VP and inclined to HP. Okay, so we have to draw the true shape of the section also, that we will discuss after discussing the sectional view. How to draw the sectional view, that firstly we can discuss, and after that we can go to the true shape of the section. Okay, so let's watch this video. The object is placed on HP, then it is cut by a section plane which is perpendicular to vertical plane. You can see that the section plane is perpendicular to vertical plane and inclined to HP. Okay, so you can see that the front view of this section plane is a line. That means we can represent this section plane as a line in front view, or we can represent this section plane as a vertical trace in the front view. Okay. Then to obtain the sectional top view, we have to look the object from the top, and you will see the top view, sectional top view here. Okay, on HP. Then after that, to represent both views on a single plane, you can rotate the horizontal plane through 90 degree in the clockwise direction. Okay, so when we rotate the horizontal plane, you can see the sectional top view, and this is a true shape. And how to draw the true shape, that we can discuss after discussing the sectional top view and how to draw the sectional front view. Okay. So initially we can draw the reference line XY, then after that we can draw the top view. So for that, it is given that this square prism is placed on HP with one of its rectangle face inclined 30° to vertical plane. So initially we have to start with this side which is inclined 30° to XY line. So initially you can draw a line which is parallel to XY line here, that is not shown here. Initially you draw a line which is parallel to XY line by taking any distance from XY line, and draw this line which is inclined 30° to XY line, because one rectangle face is parallel inclined 30° to vertical plane. So you can start with this line which is inclined 30° to XY line, then complete this square, that is top view. Then name the coordinates like A1, B2, C3, D4, etc. Not A1, B1, C1, D1, etc. You can name the coordinates as A1, B in bracket 2, C3 in D in bracket 4, like that. Okay. Then after that you complete the front view, and also you know how to represent the coordinates in front view. You represent all the coordinates and draw the section plane. So as per this question, it is given that the section plane is passing through a point in the axis which is 20 mm from the top. So you locate a point on the axis which is 20 mm from the top. You locate a point here which is 20 mm from the top, and through this point you can draw the section plane which is inclined 60° to XY line. So through this point you can draw a line here which is parallel to XY line, and you can draw this line 60 inclined to XY line. Okay, so draw the section plane. Initially you locate a point 20 mm from the top here and draw a line here which is parallel to XY line, and from this point you can draw a line that is a section plane which is inclined 60° to XY line. Okay, then mark the section points. You can mark the section point, you can start from this point. So you can mark the first point here, then second visible edge is this point. So initially we can mark the section point on the visible edges. So first visible edge is here, so the first point here. Second visible edge is this edge, so second point is here. Then third point on this edge BC, on this line. So we locate point 3 here, and also one more point is here, that is on CD. You can locate point 4th point, and then you can locate the 5th point here. This is not the correct point. Here you can locate the 5th point. Okay, then after locating the point, you can project all the points into the corresponding edges in the top view. So when we project this point 3 and 4, you know, the first point is on, the third point is on BC, so you can project this third point into BC, and fourth point is on CD, so project the fourth point into CD here. Then fifth point is on this line, so you can project this point into here. So this is the fifth point. Okay, this is not the correct point, this is the fifth point. Then first point is on this line, so when we project that point, you can locate this point here. Okay, project all these points. So after projecting all the points, it has this section to obtain the sectional top view. So, and you know, the sectional top view is not the true shape of the section, which is only the apparent shape. So we have to draw the true shape also. So for that, we have to consider another plane. Okay, so another plane which is parallel to this section plane. So I draw a line x1 y1 which is parallel to this line. You can take any convenient distance from this line, any convenient distance, and draw this line x1 y1. Then you can draw lines through all these section point which is perpendicular to this section line, like this, to any convenient line. Okay, then after that we have to locate all the point 1 2 3 4 5 here to draw the true shape. For that, you know, you can take the distance of point 1 from xy line and mark that point here from x1 y1. That is, take the distance of this point 1 from xy and mark the distance from x1 y1 here. Then similarly, you can take the distance of point 2 and mark the point which is drawn through 2 dash here. Okay, then take the distance of 3 and mark the point which is drawn through 3 from x1 y1. Then take the distance of 4 and mark that point from x1 y1 on this line, because 3 4 on the line 3 4. Then join all these points. Similarly, you locate point 5. This is not the actual line. We have to draw the line actually through this point, because actual point 5 is here. Okay, this is not correct. So we have to draw the line from this point in this direction and locate point 5 here. This is not the actual position. Okay, join all the points by frame lines and hash the section. So this is a true shape. Okay, I think you understand this problem. Then next we can move to another problem. This is a pentagonal pyramid of base 35 mm and height 60 mm rests with its base on HP such that one of its base edges is perpendicular to VP. You know how to draw the top view and front view when the solid is resting on HP such that one of its base edges is perpendicular to VP. Okay, then a section plane inclined 45 degrees to HP and perpendicular to VP cuts the pyramid through its axis 25 mm from the apex. Draw the sectional front view and true shape of the section. First, let us see the video. So it's the initial position of the solid. Then the object is cut by section plane. Then the portion is removed. Then look from the front. You will see the front view after the sectioning. Look from the top view, and you will see the top view, and you will get true shape. Then you rotate the horizontal plane through 90 degrees in the clockwise direction to represent both views on a single plane. And you know, this is the top view, sectional top view, and this is the true shape. Okay, then we can draw this figure on a drawing sheet. So this is a fine figure, and we can see how to draw this fine figure. First you draw the reference line xy, then one base edge of the solid is perpendicular to VP, so you can start with one base edge perpendicular to xy line in top view, either on the left side or on the right side. That's not a problem. Then you complete the front view. Then draw the section plane, and as per the condition is given that the section plane passes through a point 25 millimeter below the apex. So you can locate a point on the axis here, this point, which is 25 millimeter below the apex, and you can draw initially a line through that point, which is parallel to XY line, and from that point you can draw this section plane, which is at an angle 45 degree to XY line. Okay, then after that you can mark the section points. The first point is on initially you can mark the section point on the visible edges in an order. That is, first point is on AO, first point, second point is on BO, second point, third point is on CO, this is the third point, and then fourth point is on DO, and final point is on EO. Okay, then after locating all the points, you can project all the points into the corresponding edges in the top view. Okay, the corresponding edges in the top view, 1 2 3 4 5 etc., and you join out the point and has the section. Then to draw the true shape, here also the section plane is inclined to HP, so we have to draw the true shape, because neither front view nor top view gives true shape. So you consider another plane which is parallel to XY line. You can draw this section plane and this plane, that is X1 Y1, here or in the top here, this top place. Okay, then draw a line which is perpendicular to the section plane through all the section point to any convenient length. Then you can locate the point 1 2 3 4 5. You know how to locate this point. I will explain once more. You can take the distance of point 1, perpendicular distance from XY, then mark that distance on the line through point 1 dash from X1 Y1. So take this distance and mark the distance from X1 Y1 here on the line which is drawn through 1. Similarly, you can take the distance of 2, perpendicular distance 2 from X1 Y1 XY, and you can mark that point on the line which is drawn through 2 from X1 Y1. The distance should be taken from this line, Okay, similarly you locate 3 4 5 and join all the points and has the section. Okay, so this is the final figure. Dimension should be given after drawing all the lines and all. Then it is better to represent the plane or the front view which is below the section plane as thick line, using thick line, and the line which is above the section plane, that is the plane or the portion which is removed, should be represented by using thin lines. Okay, I hope you understand this problem. Okay, thank you.